Finite math. In this video, we're going to solve systems of equations. There are three possible answers for a system of equation, and we're going to talk about that. Solve using a graph, solve using the substitution method, and finally, we're going to solve using the addition or elimination method. As you go through the video, you're going to notice on the top left some icons. This icon will talk about the process to do each of these. Examples, some practice for you, and then finally a self-quiz. Then we're going to talk about what you need to do to get really good at this. Remember, it's not magic, it's math. So let's get started. A solution of a system of linear equations is an ordered pair that makes both equations true at the same time. There are three possible solutions to a system of linear equations. The first solution is called consistent. That's where we get one solution. That's when two lines intersect. For instance, the example here intersects at 3, 2, and that's the solution. We could also have no solution. This is called inconsistent, and that's when we have parallel lines. They'll never intersect, so there's no solution. We could also have infinitely many solutions. That's called dependent. This is when we have the same line. Let's look at the possible answers that we could have. Now, let's look at what Math Excel or MyLab Math talks about. It says, select the correct choice below, and if necessary, select the correct choice below, and if necessary, fill in the answer box within your choice. A is there's a solution, so that's one solution, and you type in an ordered pair. For this one, it would be 3, 2. B says there are infinitely many solutions, and that's a dependent solution. That means we have the same line. And for C, there's no solution. Well, that's inconsistent. That's straight down here. Those are parallel lines. So those are your three choices when you do these. We will learn three ways to find the solution: by graphing, substitution, and the addition or elimination methods. Let's solve this system by graphing. Our system consists of 2x minus y equals 3 and x plus 2y equals 4. We're going to graph both of the lines on the same Cartesian plane. Let's graph the first line, 2x minus y equals 3. We want it to look like y equals mx plus b because that's the easiest way to graph. To do that, I'm going to subtract 2x from both sides, but now I need to get a positive y, so I'm going to divide everything by -1. This gives us y equals 2x minus 3. Cool! What I like to do is write y equals mx plus b right underneath it. The reason is, when I circle straight up, I get my slope, which is 2 over 1. Remember, we have to have a fraction because it's rise over run. And then my y-intercept, which is -3. The first thing we need to do is graph the y-intercept at -3. Now, we need to follow our rise over run. From our y-intercept, we're going to go up 2 over 1 and put a dot. Up 2 over 1 and put a dot. And graph our line and label it. Let's look at the second line. Our second line is x plus 2y equals 4. Once again, I want it to look like y equals mx plus b. I'm going to subtract x from both sides, which gives us 2y equals -x plus 4. I need to divide everything by 2, and that is y equals -1/2 x plus 2. Once again, I like to write y equals mx plus b right underneath it because I can circle my slope, which is -1/2. Remember, we need rise over run, and my y-intercept, which is 2. The first thing we graph is our y-intercept of 2. Then we have to follow our slope. Since it's a -1 for rise, we go down 1 and over 2 from our y-intercept. And let's do it again. Cool. We're going to draw our line and then label it. Let's look at our possible answers. Select the correct choice below and, if necessary, fill in the answer box within your choice. This one has a solution because they intersect. Answer is A. The solution is 2, 1 because that's where they intersect at. It's super important when you're doing this to make sure you write your ordered pair in parentheses, especially if you're using a computer program. If you don't, it'll be marked wrong because an ordered pair is always in a parentheses. Let's look at another one. Let's graph negative x plus 3y equals 9 and negative 2x plus 6y equals 18. We're going to graph the first one, negative x plus 3y equals 9. Just like we did the first one, we're going to solve for y. I'm going to add x to both sides and then divide everything by 3. This gives me y equals 1/3 x plus 3. I'm going to write y equals mx plus b right underneath it. I'm going to circle my slope, which is rise over run, and my y-intercept, which is 3. We always graph the y-intercept first, so I'm going to put a dot at 3 on my y-axis. Now, we have to follow our slope. Rise means we're going to go up 1 and then over 3. So from our y-intercept, we're going to go up 1 over 3, up 1 over 3, and graph it, and then label it. Let's do the second line. Negative 2x plus 6y equals 18. I'm going to add 2x to both sides. I have to divide everything by 6 because I'm solving for y. Now, I'm going to write y equals mx plus b right underneath it. Now, I can circle my slope, which is 1/3, and that's rise over run. I'm going to circle my y-intercept, which is 3. We always graph the y-intercept first, so I'm going to put a dot at 3 on the y-axis. I'm going to follow my slope, which is up 1 over 3. So I'm going to go up 1 over 3 for my y-intercept and up 1 over 3. I'm going to graph it, label it, and hopefully you notice something interesting. They're the same line. Let's look at our possible answers. Select the correct choice below and, if necessary, fill in the answer box within your choice. Well, it's not A because we don't have one solution. It's B. There are infinitely many solutions. Why? Because they're the same line. Let's do one more together. Solve the system of equations by graphing. Our two equations are x minus y equals 5 and negative x plus y equals negative 3. Let's graph the first line. X minus y equals negative 5. We want it to look like y equals mx plus b. I'm going to subtract x from both sides, and then we need y, so I'm going to divide everything by negative 1. This gives us y equals x plus 5. When I write y equals mx plus b right underneath it, I can see that my slope is 1, which is our rise over 1, and then my y-intercept is 5. We always graph the y-intercept first, so I'm going to put a dot at 5 on the y-axis. My rise over run tells me I'm going to go up 1 and over 1 from the y-intercept. So let's do it. Up 1 over 1, up 1 over 1. I'm going to graph it and label it. Let's look at the second line. Negative x plus y equals negative 3. Once again, I have to get y by itself. I'm going to add x to both sides, and right away we have it in slope-intercept form. I'm going to circle my y-intercept, which is 1. Remember, we need a fraction because we have to figure out our rise over run. And then, of course, my y-intercept is negative 3. We're going to graph the y-intercept first, which is negative 3. Now, we're going to follow our slope. And our slope says we're going to go up 1 over 1 from our y-intercept. So let's do it. Up 1 over 1, up 1 over 1. Cool. And then we're going to label it. Interestingly, these two lines have the same slope, but different y-intercepts. That tells us they're parallel. So select the correct choice below. If necessary, fill in the answer box within your choice. Well, this one's going to have no solution because they're parallel and they'll never intersect. Here's the first one for you to try. You're going to solve this system of equations by graphing. Pause the video, do it, and then press play and we'll work it together. Let's see how you did. So the first equation is 2x minus 3y equals 6. I'm going to subtract 2x from both sides, and then to get y by itself, I'm going to divide everything by negative 3. This gives us y equals 2/3 x minus 2, which is perfect for a slope-intercept form. I'm going to circle my slope, which is the rise over run, and then my y-intercept, which is negative 2. We always graph the y-intercept first at negative 2. From the y-intercept, we're going to go up 2 over 3. We're going to rise 2, run 3. Yep, up 2 over 3, up 2 over 3, and graph it and label it. Let's look at our second equation. X plus y equals 3. I'm going to subtract x from both sides, and right away, it's in slope-intercept form. I'm going to circle my slope, which is negative 1. Remember, that's rise over run. And then my y-intercept, which is 3. First thing we do is we always graph the y-intercept at 3. And now we're going to follow the slope. Since my rise is negative, I'm actually going to go down 1 over 1 from the y-intercept. So let's do it. Down 1 over 1, down 1 over 1, graph the line and label it. This is pretty cool. Do you notice that they intersect? Yep. So select the correct choice below, and if necessary, fill in the answer box within your choice. Well, the answer for this one is it has a solution, and the solution is 3, 0. Remember, we always have to put it as an ordered pair, or it's going to get marked wrong. Try these two also by yourself. Pause the video, do them both, and then press play to check. Let's look at the first one. X plus y equals 2 and y minus x equals 2. We're going to graph the first equation, x plus y equals 2. I'm going to subtract x from both sides, and right away we get our slope-intercept form, y equals negative x plus 2. I'm going to circle my slope, which is negative 1. I'm going to write it as negative 1 over 1 for my rise over run. And my y-intercept is 2. We graph the y-intercept first, and then we're going to go down 1 over 1, down 1 over 1 for our slope, draw the line, and label it. Let's look at the second equation. Y minus x equals 2. I'm going to add x to both sides, and once again, it's in our slope-intercept form right away. Y equals x plus 2. I'm going to circle my slope, which is 1. We're going to write 1 over 1 for rise over run. And my y-intercept is 2. We're going to graph the y-intercept first, which is 2. Then we're going to follow our slope. Up 1 over 1, up 1 over 1, draw the line, and label it. Let's look. Is our answer A, B, or C? If you said A, you are correct because there is a single solution, and that solution is at 0, 2. You're going to notice that in this, we have 0, 2 in parentheses. Super, super important. Let's do the second one. We're going to graph the first equation first. 2x plus 3y equals 6. I'm going to subtract 2x from both sides and then divide everything by 3. I'm going to write y equals mx plus b right underneath it, and we can see that y equals negative 2/3 x plus 2 is in slope-intercept form. I'm going to circle my slope, which is negative 2 over 3, and my y-intercept, which is 2. First, we graph the 2 on the y-axis. Then we follow our slope. So our slope actually says negative 2. So we're going to go down 2 over 3, down 2 over 3, graph the line, label it. Our second equation is y equals 2/3 x minus 2. Hopefully you notice that it's in slope-intercept form right away. My slope is 2/3 and my y-intercept is negative 2. I'm going to graph my y-intercept negative 2 first. Then I'm going to follow my slope. I'm going to go up 2 over 3, up 2 over 3, draw the line, and label it. Now, which is our answer, A, B, or C? Our answer is A, because we have a single solution, and that solution is at 3, 0. Hopefully you put it in parentheses, because that's really important. Now, we're going to solve systems of equations using algebra. But I want to review for a second what happens when we use algebra for these 3 different possible answers. When we have one solution and we do our algebra, we'll end up with x equals a number and y equals a number. When we do parallel lines or the inconsistent, what's going to happen is we're going to end up with 2 numbers that will never equal each other. For instance, I have here 0x equals 5, 0y equals negative 12, or we can even say 3 equals 7. This will never happen. 0 will never equal 5. 0 will never equal negative 12. So anytime this happens where your solution can never happen, the answer is parallel. And if we really look at it, we'll notice that the 2 lines have the same slope but different y-intercepts. Now what happens when we do the algebra and we have the answers the same, like x equals x or negative 4 equals negative 4? Well, that answer will always be true. And for that one, we have infinite solutions. These are dependent. And if we looked at the lines, they would be exactly the same. The first ones we're going to do is called substitution. So we're going to solve the system of equations using substitution. Now we have a couple of steps here. First, we're going to solve one of the equations for either x or y. And what we're looking for is we're looking for a 1x or a 1y to solve. Then we're going to substitute the result into the other equation, and then we're going to solve for whatever variable we have left, and then substitute that answer back into one of the equations. Yeah, it seems a little weird, but let's do this one. Let's look at these two. X plus 2y equals 4, and y equals 3x plus 16. Now the first thing we want to do is solve for either x or y. When I look at these two equations, I notice that y is already solved. Y equals 3x plus 16. So number one's already done for us. Now we're going to substitute the result into the other equation. Our other equation is x plus 2y. Well, we know what y is. So what we're going to do is we're going to put 3x plus 16 in for y. We're going to have x plus 2 times 3x is 6x, 2 times 16 is 32, equals 4. Let's keep solving for x. X plus 6x is 7x plus 32 equals 4. I'm going to subtract 32 from both sides, and I get 7x equals negative 28. I'm still solving for x. I want x to equal something. I'm going to divide by 7 on both sides, and it turns out that x equals negative 4. Whenever I get x to equal a number, I know that my answer is going to be A. There's going to be a single solution. We found x, but now we have to find y. And how to do that is we're going to substitute negative 4 into x, into either equation. It doesn't matter which one you use. I decided to use the second one. You can use the first one, doesn't matter. So what I'm going to do is I'm going to put negative 4 in for x. 3 times negative 4 is negative 12. Negative 12 plus 16 is 4. So it turns out that our answer is A, and the solution is negative 4, 4. Remember, we have to put it into an ordered pair. Let's review for a second. First thing, we have to solve for a letter, x equals or y equals. In this case, it was already solved for us. We substitute what we found into the other equation. We solved for the variable that's left, and in this case it was x. When we found x equals negative 4, we substituted negative 4 into either of the equations, and I decided the second one. For this one, we get y equals 4, and that's our solution. Let's try another one. Solve this system by the substitution method. We have x plus 5y equals 34, and 2x plus 5y equals 38. Now the first thing we want to do is we want to solve for either x or y. Now when I look at my two equations, I have x plus 5y equals 34, and I have 2x plus 5y equals 38. Which one of these has a 1 as a coefficient? Do I have a 1x or a 1y? We do. And it's in this one, x plus 5y equals 34. This is the easiest one to solve for because we're not going to divide anything. I'm going to subtract 5y from both sides, and now we have x equals negative 5y plus 34. We're going to take that, and we're going to substitute that into the other equation, okay? It has to be the other equation. And for us, it's 2x plus 5y equals 38. I like to make a big space, and I'm going to put negative 5y plus 34 in for x. Now, we need to solve for that variable. So I'm going to do 2 times negative 5y is negative 10y, 2 times 34 is 68, and then the rest stays the same. I like to put like terms next to each other, so that's why I have negative 10y plus 5y plus 68 equals 38. Negative 10y plus 5y is negative 5y plus 68 equals 38. We're solving for y, by the way. I'm going to subtract 68 from both sides, divide by negative 5, and it turns out that y is 6. Now right away, since I have y equal to a number, I know my answer is going to be A. There's going to be a solution. The only thing is, we have to find x. What we're going to do is we're going to pick either one of our equations. I decided the second one. You can use the first one. Doesn't matter. But I'm going to substitute 6 in for my y. 5 times 6 is 30. I'm going to subtract 30 from both sides, divide by 2. All I'm doing is basic algebra here, okay? And then I get x is 4. My answer is A. There's a single solution. And what's that solution as an ordered pair? Parentheses, 4, 6, and parentheses. And that's really all it is for the substitution method. Whenever I see the word substitution, I know I'm going to be putting something in for something else. So when I'm taking the test, that's kind of a tip for me how I'm going to solve it. All right, you're going to try these two by yourself. You're going to pause the video, do them, and then press play to check. All right, let's see how you did. So the first one says, solve the system by the substitution method. We have 2x plus 7y equals 10, and we have x minus 2y equals 5. The first thing we're looking for is we're looking for an x by itself, a 1x. And in this case, we have it right away. X minus 2y equals 5. What we're going to do is we're going to add 2y to both sides, and now x equals 2y plus 5. The next thing we're going to do is we're going to substitute 2y plus 5 in for x in the other equation. So our other equation is 2x plus 7y. I like to make a big space for my x, 2y plus 5. And now what we're going to do is we're going to solve for y. So 2 times 2y is 4y. 2 times 5 is 10. 7y equals 10. I like to put like terms next to each other, so that's what I did next. 4y plus 7y is 11y plus 10 equals 10. I'm going to subtract 10 from both sides, and now I'm going to divide by 11, so y is 0. Right away, I get y equal to a number, so that tells me my solution is going to be A. I have y, now I have to find x, so I have to back substitute. It doesn't matter which equation you use. For this one, I decided to use the second one. All we have to do is put our answer for y, which is 0, in for y. 2 times 0 is 0, so we get x equals 5. Our answer is A, and the solution set is 5, 0. Remember to put it in parentheses. Let's look at the next one. 3x plus y equals 0. Negative 12x minus 4y equals 5. First thing we have to do is we have to look for a 1y or a 1x. Hopefully you see it right away. 3x plus y equals 0. We want to solve for y. I'm going to subtract 3x from both sides, so y equals negative 3x. You could also write y equals negative 3x plus 0. The next thing I'm going to do is I'm going to substitute negative 3x in for y into the other equation. It's really important, the other equation. I like to put a parentheses in for my variable y, and we put negative 3x in there. Now we're going to solve for x. So we're going to have negative 12x plus 12x, because a negative times a negative is a positive, and that equals 5. Negative 12x plus 12x is 0. Now here's one of those weird cases. Will 0 ever equal 5? Will that ever be true? No, it's never true. And since it's never true, there's no solution. Since there's no solution, these two lines are parallel. They have the same slope. Well, let me prove it to you. 3x plus y equals 0. If I subtract 3x from both sides, I end up with y equals negative 3x. Well, let's look at negative 12x minus 4y equals 5. I'm going to add 12x to both sides and then divide everything by negative 4. And would you look at that? I have y equals negative 3x plus 5. They have the same slope, but different y-intercepts. That tells us they're parallel. The addition method. Now this is the last of the three methods we're going to look at. How do you do it? Well, I want to mention that sometimes the addition method is also called the elimination method in some books. First, we need to make sure that our x and y's are lined up. What we're going to do next is we're going to add straight down because we might get lucky. That means we're looking for a 0x or a 0y. If we don't have a 0x or a 0y when we add straight down, we need to multiply either the first equation or the second equation or both of them so that when we do add down, we have a 0x or a 0y. We'll solve for the variable that's left and then back substitute. All right, let's do one. The first thing we have to do is make sure that our equations line up. Well, I have 3x, and indeed, the x's are on top of each other, the y's are on top of each other equals a number, so that one's done. Now, we're going to add straight down to see if we can get rid of an x or a y. So let's add straight down. 3x plus 4x is 7x. 6y minus 6y is 0y, yay! And 9 plus 12 is 21. We got lucky, because what we want is we want a 0y. Why do we want that? Well, because 0 times anything is 0, and we can go straight to solving for x. We don't need to multiply anything. We don't need to add down to eliminate. Nope, we go right to solve the variable by itself. We have 7x equals 21, divide by 7, and x equals 3. Now we do exactly like we did for substitution. We're going to substitute 3 back into x in either one of our equations. So that was step 5. Number 6, we're going to back substitute. It doesn't matter which equation you use. I decided to use the first one. You can use the second one. Doesn't matter. But what I'm going to do is I'm going to put 3 in for x. 3 times 3 is 9. I'm going to subtract 9 from both sides. And then to get y by itself, divide by 6. So y is 0. Well, right away, when I had x equals 3, I know that my answer is going to be A, because x is a number. We just had to solve for y. So my answer is A. There is a single solution, and that solution is parentheses 3, comma 0, and parentheses. Remember, you always have to have it as an ordered pair. Let's look at this one. Solve by the elimination method. 2x plus 8y equals 4, and 3x minus 8y equals 6. The first thing we want to do is make sure that our x's and y's line up. And they do. The x's are on top of each other, the y's are on top of each other, equals, and a number. Now, we want to just add straight down to see if maybe we get rid of something. Well, when you add straight down, 2x plus 3x is 5x, 8y minus 8y is 0, yay, and 4 plus 6 is 10. Right away, we get a 0y. And that makes our life really easy because all we have left is 5x equals 10. I'm going to divide by 5 and x equals 2. Now, I've mentioned this before. When I get x to equal a number, I know that I'm going to have a single solution. But I have to find y to figure out that solution. Now, we're going to back substitute. Doesn't matter which equation you use. I decided to use the second one. I'm going to put 2 in for x. 3 times 2 is 6. Subtract 6 from both sides. Then I have to get y. I'm going to divide by negative 8, and y is 0. So, my answer is A, the system has a single solution, and that solution set is 2, 0. Remember to put it in parentheses. So let's review for a second addition method. You need to make sure the x's and y's line up. You're going to add straight down, and we're going to cross our fingers that we get a 0x or a 0y, because then it's super easy to solve. But if we don't, we have to multiply one or both of the equations by a number. And I'm going to show you an example of that in a second. Then when we add down and we get a 0x or a 0y, we're going to solve for the variable, back substitute, and get our solution. Easy peasy, right? Let's look at another one. Solve by the elimination method. 5x plus y equals negative 16. 7x minus 3y equals negative 40. The first thing is they line up. X's are over x's, y's are over y's. Let's add straight down to see what happens. Well, 5x plus 7x is 12x. Y minus 3y is negative 2y. And then negative 16 minus 40 is negative 56. Sadly, we don't get a 0x or a 0y like we did before. This means we have to multiply one or both of the equations so that when we add down, we do get a 0x or a 0y. So let's look at our equation. So we have 5x plus y equals negative 16. 7x minus 3y equals negative 40. I have 5x and 7x. If I multiply the first one by negative 7 and the second one by 5, that'll give me negative 35x and positive 35x. And that would give me 0x. So I could multiply the first equation by negative 7 and the second equation by 5 to get rid of the x's. What about our y's? I have y and negative 3y. If I multiply the first equation by 3, I would end up with 3y. If I multiplied the second equation by 1, or just leave it alone, I would end up with negative 3y. What I like to do is the one that's the easiest, the one that has the least work, and that would be getting rid of the y's. It doesn't mean you can't get rid of the x's, but the fewer steps you take, the fewer times you could make an addition or subtraction multiplication mistake. I'm going to multiply the first equation by 3. So 5x times 3 is 15x. Y times 3 is 3y, and negative 16 times 3 is negative 48. The second equation I'm just going to leave alone, because now when I add straight down, I have 15x plus 7x is 22x. 3y minus 3y is 0y. And negative 48 minus 40 is negative 88. Woohoo! We have a 0y. So this gives us 22x equals negative 88. Now we're just going to solve for x. Divide by 22 on both sides, so x equals negative 4. I have x equal to a number, so now I know my answer is A, but we have to find y. We're going to back substitute. Doesn't matter which equation we use. I decided to use the first one. You could use the second one. I'm going to put negative 4 in for x. That gives us negative 20 plus y equals negative 16. Add 20 to both sides. That gives us y equals 4. That means our answer is A. There's a single solution, and that single solution is negative 4, 4. Let's look at this one. Use the elimination method to solve the following system of equations. We have 5x minus 8y equals 0, and 10x plus 6y equals 0. First of all, the numbers line up, so it's super awesome right there. Now what we're going to do is we're going to add straight down. That gives us 15x minus 2y equals 0. Well, we don't have a 0x and we don't have a 0y. So what we have to do is decide what are we going to get rid of, the x's or the y's. Let's look at our x's. If I take 5 times negative 2, I get negative 10x. And if I just multiply by 1 or leave it alone, I'll get 10x. Negative 10x plus 10x is 0x. So I could get rid of the x's. Let's look at the y's. I have negative 8y and 6y. If I multiply the first one by 6 and the second one by 8, I'll end up with negative 48y and positive 48y. Once again, when I add down, I end up with 0y. For this one, the easiest one to get rid of would be the x's. Of course, it doesn't matter, but I'm going to get rid of the x's because all I have to do is multiply the first row by negative 2. And we're going to do that. 5x times negative 2 is negative 10x. Negative 8y times negative 2 is 16y, and 0 times negative 2 is 0. The second equation we're going to leave alone. Now, we're going to add straight down. Negative 10x plus 10x is 0x, and 16y plus 6y is 22y, and we get it equal to 0. Woohoo! We have 0x. Well, 0 times anything is 0. Now, we're just going to solve for y. I have 22y equals 0. Divide by 22 on both sides, and we have y equals 0. This tells me that my answer is A, the system has a single solution, but we have to find x. And we're going to back substitute. It doesn't matter which one we back substitute into. I decided to use the first one. You could use the second one. I'm going to put 0 in for y. Negative 8 times 0 is 0, so I have 5x equals 0. Divide by 5, and it turns out that x is also 0. So our answer is A, the system has a single solution, and the solution set is the ordered pair 0, 0. You're going to do these two by yourself using the elimination or addition method. So pause the video, do them, and then press play, and we're going to work them together. Let's look at the first one. 5x plus 4y equals negative 30. 3x minus 9y equals negative 18. When we add down right away, we end up with 8x minus 5y equals negative 48. Well, we don't get a 0x and we don't get a 0y. So that means we need to either So now we have to decide, are we going to get rid of the x's or the y's? Let's look at the x's for a second. I have 5x and 3y. If I multiply 5x times negative 3 and 3x times 5, I'll have negative 15x and positive 15x. That will give us 0x, so that's an option. Let's look at our y's. I'm going to take 4y times 9 and then negative 9 times 4. This will give us 36y and negative 36y. When I add down, I end up with 0y. Now, it doesn't matter. Either one, we're going to have to multiply both of the equations. I decided to get rid of the y's for this one. So I'm going to multiply the first equation by 9. 5x times 9 is 45x. 4y times 9 is 36y. And negative 30 times 9 is negative 270. I also have to multiply the second equation by 4. 3x times 4 is 12x. Negative 9y times 4 is negative 36y. Negative 18 times 4 is negative 27. Now when I add down, 45x plus 12x is 57x. 36y minus 36y is 0y. Woohoo! And then negative 270 minus 72 is negative. And then negative 270 minus 72 is negative 342. Awesome, we have a 0y. 0 times anything is 0. That gives us 57x equals negative 342. Divide by 57, and x is negative 6. Since we get x to equal a number, I know my answer is going to be a, but we have to find y. We're going to back substitute. It doesn't matter which equation we back substitute into. I decided to use the first one. You could have used the second one. We're going to put negative 6 in for x. 5 times negative 6 is negative 30. I'm going to add 30 to both sides. 4y equals 0. Divide by 4, and y is 0. What is our answer? Our answer is A, and the solution set is negative 6, 0. Remember to put it in parentheses. Let's look at the second one. 3x minus 8y is 0. 6x plus 9y equals 0. Let's add down. Let's see if we get lucky. 3x plus 6x is 9x. Negative 8y plus 9y is y and equals 0. No, we don't get lucky. We don't get a 0x and we don't get a 0y. Let's figure out if we want to get rid of the x's or the y's or if it matters. Let's look at the x's. If I take negative 2 times 3x, I'll end up with negative 6x. And negative 6x times 1, or just by itself, will give me my 0x. So that's a possibility. Let's look at our y's. I could multiply the first equation by 9 and the second equation by 8. That would give me negative 72y and positive 72y, which when we add down would give us 0y. I like to multiply by one number if I can. I'm going to get rid of the x's. I'm going to multiply the first equation by negative 2. This doesn't mean that you have to get rid of the x's. If you got rid of the y's, we'll end up with the same answer. 3x times negative 2 is negative 6x. Negative 8y times negative 2 is negative 16, and 0 times negative 2 is 0. The second equation I'm going to leave alone. Let's add straight down. Negative 6x plus 6x is our 0x. Yay! Negative 16y plus 9y is negative 7y, and 0 plus 0 is 0. We got rid of the x's. That's awesome. We end up with negative 7y equals 0, divide by negative 7, and y equals 0. Because y equals a number, I know my answer is going to be a, but we have to find x. We're going to back substitute into either of the equation. I decided to use the second one. You could use the first one. I'm going to put 0 in for y. 9 times 0 is 0. 6x plus 0 equals 0. 6x equals 0. Divide by 6, so x equals 0 also. Our answer is A. We have one solution, and the solution is 0, 0. All right, we are now to the self-quiz. What you're going to do is you're going to pause the video, complete the questions, then press play to check your answers. The idea of the self-quiz is to do these without having to look back at your notes. If you have to look back at your notes, that tells you that's what you have to practice. When we start going through these and solving, if you have any mistakes, that also tells you those are the pieces you have to practice. All right, pause the video, do the questions, and then press play to check. Let's see how you did. The first one says, solve using the elimination or addition method. I have 8x minus y equals 6 and x plus y equals 3. The easiest thing to do is to add straight down to see if we get rid of an x or a y. 8x plus x is 9x. Negative y plus y is our 0y, yay, and then 6 plus 3 is 9. We have a 0y, woohoo! Now we have 9x equals 9, divide by 9 on both sides, so x equals 1. Since we get x to equal a number, I know that my answer is going to be A, but we have to find y. We're going to back substitute x equals 1 into either of the equations. I decided to use the first one, you could use the second one. I'm going to put 1 in for x, 8 times 1 is 8. I'm going to subtract 8 from both sides, and then I have to divide by negative 1. That gives us y is 2. Our answer is A, and the solution set is 1, 2. Cool. Let's look at the second one. Solve the system of equations using the substitution method. When I look at the first equation, I have a 1x and a 1y. So I could solve for x in the first equation or solve for y in the first equation. In the second equation, I could solve for x. It really doesn't matter what you did, as long as when we get to the end, we have the same answers. I decided to solve for y in the first equation. So I'm going to subtract x from both sides, and y equals negative x plus 7. Now, we're going to back substitute. I have to take the other equation and make a big parentheses for my y, because y is negative x plus 7. Now, let's solve. I'm going to bring down my x, but negative 1 times negative x is a positive x. Negative 1 times 7 is negative 7, and then we just have equals negative 5. X plus x is 2x minus 7 equals negative 5. I'm solving for x. I'm going to add 7 to both sides. 2x equals 2, divide by 2, and x equals 1. Since I have x equal to a number, I know my answer is A. There's going to be a solution. And if there's going to be a solution, I have to find y. We're going to back substitute. It doesn't matter which equation you use. I decided to use the first one. I'm going to put 1 in for x. I'm going to subtract 1 from both sides, and y is 6. Our answer is A, and the solution is 1, 6, in parentheses. Let's look at the last one. Solve the system by graphing. We have negative x plus 3y equals 9, and y equals negative x plus 7. Let's look at the first equation. I need to solve for y. I'm going to add x to both sides, and then divide by 3. This gives us our slope-intercept form. Y equals 1/3 x plus 3. My slope is 1/3, that's rise over run, and my y-intercept is 3. We graph the y-intercept first, so I'm going to put a dot at 3. I'm going to go up 1 over 3, up 1 over 3, and draw the line. Let's look at the next one. Y equals negative x plus 7. Well, what's really cool is this one's already in slope-intercept form. My slope is negative 1. I have to write it as a fraction, so I'm going to write negative 1 over 1 for rise over run, and my y-intercept is 7. We're going to graph 7 first, so I put a dot at 7 on the y-axis. My slope is negative 1 over 1. I'm going to go down 1 over 1, down 1 over 1, draw my line, and look at that. They do intersect. That means my answer is A. The solution has one solution, and that is 3, 4 in parentheses. Woohoo! All right. Whew! That was a long one. Good job. What do you need to do next? Well, you need to practice. Okay? Practice, practice, practice. Did you like this video, even though it was kind of long? Well, then like it. Did you really like it? Why don't you subscribe? Did it help you? Well, why don't you share it with a friend? Remember, it's not magic, it's math.